This is Diveflyfish. This is the remainder of my last batch of mixed zinc oxide, Epsom salt, silica gel, galena, and iron pyrite. So again, cooked in a stainless steel crucible. I tried making little cells that would be stacked by trying to wipe some of the molten salts between this, and it was only nominally effective. What I think is necessary is that the metal needs to be immersed in the molten salts and polarized. You simply can't just spread it on easily. I did it with the pile cells, but the working time is so small and the cooling factor is so great that it's very difficult to keep this material in molten form long enough to be able to polarize it. So what I did was I took a piece of magnesium, a small magnesium strip like this, and I embedded it into the molten salt mixture. After which I did that, I took a piece of carbon, like so, and I placed that also into the molten salt mixture as close as I could get to it without touching it, and I polarized it with a 12-volt acid battery. So polarization with 12 volts. And what I have here now on this connection is that small piece of magnesium that was polarized, and you can see the oxide layer here. So that's the polarized dry oxide layer. And again, when it's dry, there's no fluid here whatsoever. So I'm going to run a couple tests with you and see what you can see with this. So again, without any form of fluid electrolyte here, I'm going to take the piece of copper and I'm going to test this to see what the milliamp hour rate is. So I'll place it on this electrode. And again, there's no fluid there. So you're seeing maybe 30 milliamp hours, something like that, which is okay again considering the size, and there's no fluid. Okay, so for an anhydrous or relatively anhydrous system here, without any fluid layer, we're getting that type of current out of it, which is sort of interesting. Okay, so I'm now going to switch it over to the voltage form, and let's see what type of voltage we can get out of this cell as well. So we are in the 2-volt range here. I believe what I have here, 2-volt range, correct. And this again is the magnesium electrode. I have the copper electrode here. And please forgive my filming, I'm trying to do this all with one hand. So what we have there is the ambient voltage, and again there's no fluid on this whatsoever, it's just the copper. I'm going to place it here. Depending upon where we put this dictates what we're getting onto from a voltage standpoint. So let's try this again. I'm just going to move this electrode so I can apply a little bit more ease of movement here. From underneath here. So again, this is the microvoltage reading without any form of fluid. Just rubbing the two electrodes together. Now, again, you can see the tenacity of this material. And I'm going to add one small drop of fluid, which is just tap water, to this, just for grins. A very, very, very small drop. Okay. Actually, that's too much. I'm going to try something. Shake it off once. So we just have an infinitely thin layer there. And now let's register it. So there we are. Depending upon where we hold this, 1.7 volts, 1.5 volts. So it's respectable. Coming from underneath where it's dry, and you can see the opposite effect. Again, if you look here, I'm going to blow this off 1 second. And again, that oxide layer is definitely there. With my finger, I'll take an instrument, this little piece of copper here. It's tenacious. Drill bit. So this stuff's not coming off. And again, if we just take a electrode here, and this is all but dry. I mean, I blew off most of the air, so that you can see that there's not much moisture necessary to attain a voltage. And again, we'll check the current. And moving it to that parameter here. And here is the dried oxide layer. And I will place, the copper electrode onto it. And there's the milliamp drop. So, in any event, I think this is worth pursuing, and I welcome any and all thoughts. Thank you for watching. Have a great night.